Not really. That's the edge of the table.
Oh yeah.
So
That's okay.
we can do sure. Go for it.
It would be cool if we had a camera up there, right?
Yeah.
Just like
How's that? Is that slightly better?
Yeah, it's all right.
Okay.
Yep.
Perfect. Then I'll be HDMI too.
Haircut?
Yeah,
Hey,
I went to a wedding, so
Oh.
I had to clean up.
How do you always
We
usually?
got a full house today.
We missed you. You're back. I'm out.
Horror movies.
Is that better? Yeah. Yes, I leave on Friday. So here for a couple of days.
Mine's hurting.
I'm just gonna mute you. And then if you want to jump in, feel free. But we're getting some feedback there. Cool. Yeah, so I wanted to just like start, I guess, by touching base and seeing what everybody's been up to and what we can do to help out. The one pull request I do want to go over and get some of Franklin's thoughts on as well is the properties in discretize. Because that'll allow us to save meshes and also be really important for interfacing with things like JIT tools. Because this is how we serialize, and so something like JSON can be written by any language.
Okay.
Yeah, so something to be mindful of. Yeah, do you want to just
Go around the
go around
table.
and see what's up? If you want stuff you want to talk about, or what are you working on these days?
Yeah, you want to start?
Well, I haven't done too much on using this lately, but I guess I was going to follow up on whether things happen with the octree mesh bug. So there seems to be sort of a shift between, I guess you create the octree mesh and then you want to, I guess, plot grid or visualize it.
Yeah.
And things were shifted. So when creating, meshes and models using octree, it wasn't sort of recognizing the bottom southwest coordinate system. So
Is there an issue on this?
there should be. Yeah.
Okay.
Yeah, you asked me to make one, so.
I'm just going to.
I think I sent you the script too. I might have sent you that over Slack.
Yeah, I'm not the best person to contact right now, but that's okay.
Yeah, and Rowan was assigned to it.
Is this in discretize or is this in SimPEG?
Probably in SimPEG.
Okay. Okay, I see. So this one.
Mm-hmm.
Okay. What we can do. Yeah, we'll bring that over to discretize because that's actually the package that it's relevant to. So I'll migrate this issue and we'll close it here. And then that should be an easy fix.
I think so too. I think it's just when you're plotting it, it's shifted because I have a feeling that the actual mesh when you create it is correct. It's just the visualization is incorrect.
Okay.
And and things related to the model as well.
Okay. And what are you using the octree for?
I wanted to run time domain EM code, so pretty straightforward. I wanted to predict TEM anomalies from spherical objects or plates, so that I can go and do some problems later. So mostly just doing it to create synthetic data. But I can add when I'm done, I can add the example to the website because it's thorough and it's a really good introductory example.
That would be awesome.
But yeah, that's about it.
So again, I worked on the sensitivity weight.
That's true.
Yeah, that looks pretty good. You want to pop my screen?
Sure. Craig, I'm just going to mute you right now. Feel free to unmute if you have something to jump in on.
Oh, sorry. Yeah, I'll mute my.
Okay.
You
Thanks.
can mute people, huh? Because you're the admin.
Yeah.
Oh, nice. Good to know. Yeah, no sensitivity waiting. That's a DC problem, DC 3D.
Okay.
And it's always the same problem that the source receivers have the highest sensitivities. So how to compensate for them. And also right now I'm working on the local problem, sensitivity problem, where we're gonna do like a local global.
Okay.
Yeah. So I managed to do the volumes, right? That's the only thing we're missing. When we're gonna send the combo objective function, we need to send sensitivities, like communicate the local to global sensitivities, and that's done on the volumes. It's scaled by the volumes. So this weekend I managed to scratch out how to get volumes.
And are you doing that through the combo objective function?
Yeah, it will become objective function. So right now the combo works with the wires.
Yep.
Right, but then currently the wires are only like ones and zeros. It's basically just grabbing the right cells, putting in the right place. We need to add a layer on top of this that is weighting, because multiple cells are going to be talking to one cell. So we're kind of projecting local meshes to global mesh.
Yeah.
So there's some averaging of sensitivities that needs to happen.
Okay.
Yeah.
Well, as long as you got the mapping, you're good to go, right? Like as long as you got like a mapping from one mesh to other mesh, that should be handled, right?
No, I mean, okay, so we're sending small meshes to our inversion mesh, which is a global mesh.
Yeah.
We need to send the sensitivities from our local meshes to our local mesh to take our step, to take our gradient step. So you need to somehow propagate that information. It's not just a one-to-one mapping, because it's not the small. You're not necessarily going to have one cell that's going to fit exactly inside one cell of the large one.
Right,
Because you're going to have padding cells and stuff.
So, but it depends how you define, right? Like if you define your sensitivity is some sort of like a normalized sensitivity as a volume.
Yeah.
Right. Which now, like if you divide by that as a volume, it's not now. It's like more like a function, right? Rather than like kind of discretized sensitivity.
Yeah, that's right.
So that's the idea, right? Like, rather than, because like it's volume matrix. So even if you got smaller sensitivity value, but if you got a really big volume, what you ended up getting as a value for that cell is big.
It's big, exactly.
So you want to compensate that as somehow.
That's right.
By dividing by that as a volume, then you can get some sort of just functions. Now, in that function space, you can basically just like move from one to the other, right? So it depends upon your operator, right? Like if you multiply volume after you map, then you don't really need to worry about that, I guess.
No, but that means you would need to scale down locally. I guess you want to scale down locally by volumes and then upbuild.
Yeah.
Oh yeah, that's an idea.
Yeah. So then I think still you just need a mapping, and then mapping goes one way, but depends upon like how you do it. It could be just a transpose.
No, it's not. Yeah. So you will need to the transpose action and the normal and the transpose need to be reweighted, right? Because your rows, it's not going to be equal to 1. Your columns are not necessarily going to add up to 1 when your columns add up to 1. So I just need to figure out a way to, when you do the transpose operation, to change it.
Do you need a separate operator to do that, like going one way or the other?
That's right. Because one way is going to be sensitivities. That's fine, can do it. But then we need also to map the other way, model values back to our local meshes, right?
Yeah. Okay. I'm not sure at this point, but
I read Dequan's thesis, and he did everything in terms of volume.
Right, but isn't it like kind of he wrote it as a transpose, right? Like kind of that interpolation matrix stuff, right? That's what I thought.
Well, it's never explicit on
I think it's just a
form.
question of order of operations, because if you do it in one, like basically interpolation operation that includes the volume, then whatever you build with that matrix, you should then be able to transpose it, I believe.
No, because it doesn't mean, let's say you have a large cell in your paddings, right? So in your local mesh, you have a large cell.
Yeah.
Which will contribute sensitivities to a lot of small cells on your global mesh, right? Now, if you want to do the transpose operation, now it's an averaging, because now you're taking a lot of small cells with different values, and then you're bringing it to a large cell. So the transpose is not the same as the forward.
But Okay. If our transpose, so if P transpose P is an identity, then we're set, right? Like there's no issue, right? So that's not, is that,
That's right.
okay.
But it should then just be like this, in this case, we're not dealing with the square matrix, right?
No,
So
it's
it
not.
should be similar to an averaging operator, how basically when we take the transpose of an averaging operator, you're like extrapolation. Sort of. But I agree, there's something subtle.
Yeah, I'll keep digging anyway. That's what I'm working on. I'm not done yet.
Okay.
Yeah.
I haven't looked at the mapping that I wrote before.
Yeah, I do. Of course,
Just
I'm working off of
I think it does have a mapping. So I thought like that's not, because.
Well, you're using a distance as your weights, right? You're
Right.
using 1 over R as your weights. Here we need to transform that to a volume. So that's what I did this weekend. Now I need to make sure that when we did the forward and the transpose, that the operation is mapping things, you know. The values are.
Right, then, yeah. So, because like we're gonna do this adjoint test, right? And like for instance, J back goes 4-way, JT back we need a
Comes
P
back.
transpose, right? So that should not exactly match. At least like we need to get a good ballpark of
Yeah,
that. So we probably need to make sure that operation is kind of
Yeah, we'll just
similar.
test it.
Yeah.
Once we have it, then it's nice because we can do tiled codes.
Yeah, that'll be really cool.
So are there pieces that you need, like support-wise?
One thing is that the mesh-to-mesh topo that you wrote should be replace probably the mesh-to-mesh, because we have a mesh-to-mesh and mesh-to-mesh topo, but they're doing the same thing, just one is using all actives and then one is as like.
There's a little bit of difference because mesh-to-mesh, the original mesh-to-mesh actually uses SimPEG interpolation.
Oh, that's right, you're using
Which is,
PDA3.
kind of painful in a big 3D mesh. It still works, so for a small problem, you can still use it. I think 2D, I think that's probably better, I guess.
Okay.
Yeah, well, it's all about like this, how to form this P matrix and how to make it efficient.
Yeah.
Right. That's the ticket. Like other things are.
Does CKD3 works on arctree and cylindrical?
Doesn't matter.
It doesn't matter.
Well, KD3 is like doesn't really know what the mesh structures are.
Because you send in the nodes on.
Yeah. So you just basically send in the location that they find like some sort of tree structure of that, and then they have certain way to
Index.
query that fast. So
That's true. So it doesn't matter. So yeah,
So should we just be using?
I think so.
I think that was what Ron said, but a long time ago. We could probably like put that into our mesh class. So mesh.ckd3, that actually generates all the tree structures of the cell, of the cell center, for
Yeah.
instance.
Yeah.
Then we could either store it. So
Yeah.
once that's stored, making an interpolation matrix is pretty fast.
Yeah.
So you don't need to regenerate that.
Mhm.
So rather than actually doing outside, like if you store in a mesh, I think that's probably better.
Would you mind starting an issue on that in discretize?
Yeah, I'm relying a lot on mesh-to-mesh topo for a lot of different pieces, and every time I'm like freezing it or like commenting it out to be able to push, and it would be nice if it's unfolding.
Yeah.
Yeah, it's a really good function.
Yeah, because if we, like, and that shouldn't be a hard thing to implement, just we'll have a quick discussion about it and then bring it over.
That'd be sweet.
Yeah, there are quite a few technical questions, like what that weighting, weighted average. I'm not 100% sure that's okay to use.
Well, we can put switches, right? It could be volume, it could be inverse distance. You can just leave the option how you.
Right. Yeah, what I hoped was actually getting a good interpolation. Just simple one interpolation, but fast. The other mesh, like as SimPEG case, but in a bit better way. So I'm not sure that.
Maybe is there something you wanted to jump into?
Sure, I was just gonna add to that. Actually, I wrote all kinds of algorithms using.
Pretty choppy. We're having a hard time hearing you.
Oh. Is this better?
A little bit. Yeah.
a little bit better.
Yeah, that's much better.
Okay. Yeah, I was just going to say that I implemented all kinds of interpolation algorithms in VTK. So, and depending on what you want to do, they can be quite efficient. But they have also a lot of power in terms of estimating like volumes and kind of doing things like that. But didn't really use them a lot. But it might be something worth looking into.
What's the status of VTK? Because we're struggling for a while. They're on 3 now, eh? Are they fully on Python 3?
Yeah, so I mean they fully support 3, but for some reason I haven't updated my Python 3 on Anaconda. So I don't know if they are distributing it yet with Anaconda, but you can get a Python 3 version of VTK. Yeah. They've been doing a lot of work on VTK, making it more efficient and kind of preparing for upgrades in OpenGL, because that's their underlying algorithm. So a lot of the visualization and some of the algorithms are becoming a lot more efficient because it's just they're upgrading and developing. So.
That's it for me.
Are there things that you want to jump in with?
Oh,
Like,
in general?
yeah.
Sure. I mean, yeah, from my perspective, it's just kind of continue with the natural source development. Yeah.
Is there anything particular on your priority list there, or just sort of general motion pieces work?
I mean, there's a lot of very specific things that I want to work on, but for now, it's mainly my thesis work.
Okay.
Generating examples, running some inversions. So I'm hoping out of that there will come some more comprehensive examples of how to run the code.
Cool.
And then there are some developments that I think will be worth kind of implementing or moving down the pipeline. I mean, I've done all kinds of stuff with the with factorization of the inverse problem, storing the factors to speed up the inversion procedure.
Yeah.
That is, I mean, it's just on my branch. It's working for me, but I know that it would take a bit of time and a bit of jointed effort to make it work for everybody.
Okay.
I'm assuming it would probably work fairly easily with the frequency domain problem because it's implemented per frequency. But yeah. But so that just allows you to store the factors for your for your system, so you don't have to resolve the A inverse, I guess, every single time that you get it.
Yeah.
It just gets stored as a dictionary currently. But I mean, that does require to have enough memory to store all the. But if you can store it, I mean, it's a speed of a factor of 5.
Sure. Yeah.
So
Yeah.
I think it would be worth trying to get that in there somewhere and figure out how we want to do it. But at this point, it's not a high priority for me personally. What else? Yeah, I mean, since I'm talking data classes, I mean, they're very relevant for me now. So, kind of figuring out a good way to just, I guess, handle it. I'm a little bit at the moment, I guess, an issue that I was having was that I couldn't serialize them effectively. So I'm really happy to see the push on discretize in terms of properties and serialization. And I think that would be a huge thing for SimPEG get that properly implemented, because I was running into some issues with some weird property saving issues, and I couldn't pickle some of the objects still, even though they should be pickable. And I mean, it just kind of boils to, it's also, I mean, we've had the conversation about just kind of reproducibility and being able to save stuff. So.
Yeah, we can jump into that at the end here a little bit, because I think that getting into discretize is certainly like the first step, and then we can start injecting further into SimPEG and giving thought on how objects need to serialize.
Yeah. Yeah, because then you could just save your inversion object.
Yeah.
And have all the information there, kind of readily accessible.
Yeah.
And same with the data. I mean, it would be very nice to be able to just serialize the data. Just
yeah, and that should not be fun to do.
No, but there are some, I guess it's the maps.
Oh, okay.
I was running into some issues with maps, and there was some of our, I haven't looked at it for a couple of months now, but I was running into some issues with, so when you unpickle the elements, there were some issues with properties being declared both as an input to the init and as a property, and it had some issues reconciling. It just gave me a number of inputs into the init for some of the classes. It just gave me an input error.
Okay.
So anyway, something to look at, and I think we had a conversation about it was an issue, I think, somewhere.
Yeah.
I can go and dig through it and see if I can find it.
Okay.
Yeah, so that's kind of, for the most part, with SimPEG, we're on that. I see some other uses for it, and I'm working on other things for work and stuff, but I'll need a bit more time to wrap my head around that.
Fair enough.
I guess probably talk about that a bit more. Sweet.
I've mostly been working on the petrophysics constraint the last 2 weeks.
Yeah.
So I have like I've been working on the 1D version that we often use.
Mm-hmm.
And now like the next step would be trying with like either like other 1D or 2D problem like DC or the 1D empty problem, and also playing them with combo objective function and having like a joint inversion with two physical property.
Mm-hmm.
So then I will be actually my first time maybe playing with wire mapping, etc. to get everything working. So that's the next step.
Cool. Anything that you need support-wise, or like examples, or?
Don't send me an example of what you're doing. I'm not sure quite yet. Like, are you storing your, like, are you inverting for two physical property, kind of? Yeah.
Yeah.
And you have store everything in a long vector.
That's right. And that's the wires, and the combo takes care of it.
So that's basically all I need. Like, I just took a brief look, but
okay.
I need to really jump into it now and make it work with this regularization that includes the petrophysics information. Yeah, for the SimPEG, that's basically what I've been working on lately. We've been working on lately. I should commit, or like I think it's really fast. It's the first commit on a branch, so like if people want to play with it, or at least it's stored somewhere now. It's better on my Dropbox.
Yeah. If, as you're working along, if there's examples or documentation or things like that that you see would be would have been useful, like small pull requests like that are super valuable. So just
I had a problem at some point implementing that, and I will try to see if I can reproduce it with like an example from one of the like normal version SimPEG.
Yeah.
That at some point, in my inverse problem, I added like a key factor in front of my data misfit, just so that sometimes I just put it at 0 and just check if my regularization is clustering thing. That's basically what it's supposed to do.
Yeah.
And I realized that actually the it's probably in the step length in the line search, but for example, if I put a key factors in front of it and like beta to 1, or if that should give the same optimization results than key factors to 1 and beta equal to 1 over this factor, we just divide by it. Like, and it's not. Actually, there is one that taking much bigger line search step, and that works way better. And the other one, it takes very long to actually converge. Like I can get to a close result, but it takes 3 times more iteration than the other case.
And so you've encountered something like that, have you not?
I did. So my case was when I think when my model parameters are really small, I think that did happen. Like, because I'm not sure the matrix in SimPEG how to handle like. No, I think mine was a bit more convoluted because I was using that beta estimate, and my model was really small. I thought that beta estimate should be enough to handle that kind of the scalings between J transpose J and the regularization.
Yeah.
But yeah, it wasn't really worked well, and I had to increase my model value somehow. It doesn't matter. It's just setting up. Oh, it's a millivolt per volt or a volt, or doesn't really matter, right? But numerically, since there's something going on, I wasn't quite sure.
Yeah. Yeah, Tito, if you have a simple example that demonstrates that, that would be super valuable.
Yeah,
because I think it should, we're probably just neglecting a scaling factor somewhere. Yeah.
Yeah, I haven't used my physically constrained example, but as I said, I'm gonna try it with DC or something like that.
Okay.
To check.
Yeah. Yeah, that would be very helpful.
Could be a precondition. I tested again the BFGS versus using Jacobi, and man, it's so much faster with Jacobi than BFGS for when you constantly update things.
Okay.
I think BFGS doesn't update fast enough if your sensitivities keep changing. So I don't know.
It doesn't really update, I guess. Right?
No, I'm not sure. We need to go line by line and solve line by line for a couple of problems, but. I switched back to the Gauss-Newton. Sorry, what's the name of that thing?
Can you just send the line of code where you make the switch?
Yeah, well, that's the thing is that you'll need to do Jacobi if you want to do that one. The projected Gauss-Newton one, because that one overrides the H approx H inverse. Otherwise, it's going to be BFGS.
Anyways. One of the things that we should actually look at is more deeply integrating the SciPy-optimize. So a lot of the stuff we have right now is our own optimization. And it would be better to be more heavily reliant on the community there.
Yes.
I actually played around with that in the past couple of weeks.
Oh, yeah?
And
with SciPy?
Yeah, it's actually really good. You can, if you feed it function handles that either give you an approximation of the Hessian, or Jacobian, or J times a vector. You just feed it the function handles as well as the other parameters, and it just does it for you. And you have probably 8 or 10 optimization approaches. There's BFGS, there's a whole bunch. So you could easily implement or quickly implement a whole bunch of different options with one call.
Just need to try. Because we could technically load just the SciPy library, right, and call them.
Yeah.
Yeah, but there's a bit of issue though, right? Like for instance, think about directives. How are you going to put the directives in that?
They always call it at the end. They always call it at the end of the solve. They're not called during the when we do projected Gaussian Newton, it just runs, and then after that when you do the step length and the directives kick in and everything.
Right. Yeah, but my point is like if you think about how SciPy optimized would work, it's not iteration by iteration, right? Like you put it in, and then they iterate, like I don't know, until they converge, right? And then output the result. But you need to output every iteration somehow, and then you need to put some directives in and kind of make it different. So that kind of that structure that they provide is not really kind of fits. So there's some details. So, and probably what we could do, we output it every iteration and then kind of reset the optimize and kind of rehandle like kind of those parameters. But I'm not sure that they are like really general enough that you could really do that type of thing.
I thought we're talking about just to solve for the step length, step direction. I mean.
No, it'll solve the whole optimization problem. I mean, you could do it. Yeah, I think you can put in a parameter that just says like do one update. You can set the amount of updates and read it out every single time.
Yeah, because we don't necessarily want it to actually go through and do
No,
the optimization. We just
not.
want to be using their algorithm to figure out that next step.
Yeah.
So
yeah.
it's
a little bit different. I mean, I'm not sure they provide that type of functionality.
Right.
To do a single step.
Okay.
But we could probably figure it out.
I think you can. There's a field that's sort of max number of iterations. You can just
Do
put
one.
in one. It spits everything out for you.
But this is also something that like we can, I think it's worth taking a serious look at and then figuring out what we actually need from SciPy Optimize. Because I mean, all that it would be to sort of get what we need out of there is a single abstraction step where they're calling a different function that computes the step and then goes and actually continues with the optimization.
Mm-hmm.
So it might actually be worth sort of pushing some input there if we can really flesh out what it is that we need and why we're not running it. So.
And I'm not sure, there are quite a few like problem-specific things, like this preconditioning stuff and
Projection.
what are you going to use that? And it's all like kind of ad hoc things and kind of fit into a certain problem, but I don't know, I'm not really sure that in kind of this general optimized package would handle those much details. So
At the end of the day, it's becoming
we could probably have some good ideas there, I guess, but I'm not sure. Just using that is, I'm not sure that's a good idea.
Okay.
Craig or Franklin, were there things that you guys wanted to jump in on?
Yeah, I was going to actually come out to UBC on Friday and talk with Sagi if that still works for him.
Yes, it does. I'm going to be around. I'm excited actually. Use it as P.
Oh, good. I'll get my data ready. Well, I actually think it is ready, so that'll be cool. Yeah, I've just got that, and then a couple of weeks ago, I was at a conference in Portland, and I was looking at interview talks, and people were doing some Bayesian version work, and so I had a go at converting one of my simple like analytic solution scripts to a Bayesian problem using PYMC3, and that turned out to be not too tricky, so that was quite cool. So I think that works pretty well for analytic solutions. I'm using it for like gravity change data where running a full mesh model isn't really appropriate. So previously I was just using the SciPy optimized curve fit to fit like 20 or so stations, but using the Bayesian approach gives you the full range of possibilities. So that's pretty cool.
Do you have an example of that?
Oh, how do you mean an example?
Or like a notebook or something that we could share and we could look at. It'd be fun to see.
I could send around kind of my scripts for like the SciPy optimized, like the curve fit versus the Bayesian. Yeah.
It'd be interesting to see, just if you have it handy, like no pressure whatsoever. But
Yep. It's basically just if you've got an analytic solution, it's fairly straightforward. Just to use that equation and then set up the prior distributions for your parameters, whether you want them normal or uniform or whatever is appropriate. And then, running it through that.
Cool.
So yeah, that's about it.
Nice. Well, it'll be fun. I look forward to hearing how Friday goes.
Yeah.
Okay, so the last thing, Franklin, do you have comments you want to jump in on, or do you want to jump to the discretize pull request? That's where I was going to go.
Yeah, I'm happy to jump to that. I mean, I've just been thinking about your issues all weekend.
Okay.
So hopefully I can make some changes to properties to help, but I don't know.
Cool. Okay, well, I'll give everybody here just like a quick overview of what that pull request is, and then I would love to hear some more of your thoughts. I'm going to share my screen. Infinite hangout loop. Okay, can you guys see that okay? So we've got a pull request started where we're looking at injecting properties into discretize. So originally when I was thinking through this, I was like trying to go way too many steps ahead. So right now this is like a minimally invasive approach to bringing properties in. So it actually shouldn't change anything user facing. All it'll do right now is allow us to serialize meshes and load meshes. And also do some things in terms of validation. So it cleans up a little bit of the init codes. So the idea being you can import it, we can create a tensor mesh, and then right now all the things that I've put onto properties are like exactly what you need to recreate the mesh and nothing more. So right now we've got our cell spacings, and which is the number of cells in each direction in our exponent. And then with that, we can always recreate the same tensor mesh. So here we can save it to JSON, and then in this case, load that back up. And so I think Franklin, you left a few comments on this guy, like on how to actually repopulate and deserialize.
Yeah.
Yeah, which is helpful. So like a couple of the things that I ran into, and Franklin and I have been having conversations on, and I'm looking for hearing some more of your thoughts, is so some of the things like n used to be a private variable. It's sort of important for the tensor mesh. The ones that are more important are really actually on the curvy mesh and the tree mesh. There's so on the tree mesh there is a vector called cells, and that actually basically describes the off-tree discretization. And that was private before, but right now it's sort of in the main namespace, which is sort of okay. The challenge is it really isn't something that like you should mess with. You should always mess with it through a utility that like refines the mesh and things like that. Yeah, so I don't know if you want to jump in and expand on that, Franklin.
Yeah, I mean, I don't know. I'm interested to talk a little bit with Rowan about this too, but I think that disallowing private properties was somewhat arbitrary. I mean, I think that there's some like best practice sort of thing. Like if you're using properties, then you're you're doing it for documentation and being open and letting people kind of discover what's going on, and it's not really something necessarily to use under the hood. But yeah, I don't know. I thought about this a lot, and I feel like that, like it's, I don't know, just since it's Python is like, it seems Pythonic to allow developers to do whatever you want, and if you want to use private properties, then that's good. And like, I feel like this is a great case for it, and like thinking advanced settings are just something that you want to serialize that maybe you don't necessarily think the user should touch. It's just cleaner to put it in properties. I don't know. I'm pretty inclined to just like delete that one line of validation, and then I think it'll all work, or that one line of whatever strangulation, and it'll all just work fine.
Yeah. Yeah, because the thing that I was also even trying to think through is if we make it a public variable, it's actually really non-trivial to come up with like the correct validations. It's because the validation step really only sort of makes sense when you're using the right utility. So when you're trying to refine the tree mesh, like I have context for what you might mess up, but just looking at the vector, I have no idea.
Yeah.
Really hard to actually like say that, hey, you shouldn't change it in this way.
Yeah.
Yeah, so that was like one of my bigger reasons for it.
Yeah, that makes sense. And then people, if they're messing with the private property, then they might not get a nice error. They might just get some ugly error down the road. And yeah, that makes sense. Yeah, cool.
Yeah, but what's really exciting about this as well, and I think it's important to think about in terms of the GIF tools side of things, is that now, like what this gives us is basically a schema for defining SimPEG meshes. And so we then, like because we can serialize it to JSON, we now actually have a well-defined SimPEG mesh that can be read into anything. And so I realize it's a little different than what the UBC meshes do, but now that we actually have, like this defines the interface and what we actually need to do to translate between them too.
Yes.
So, and then what's kind of cool too is like on then the GIF tool / UBC side, we actually now have a well-defined way to write out a UBC mesh to SimPEG.
Gotcha.
So what's gonna happen? So if I put the properties in, I'm not sure, like to my force simulation, for instance, then there's a lot of linkages, right? Problem takes the survey takes sources, receivers, like kind of informations are scattered, right, in a bunch of layers.
Yeah.
Then, okay, now I'm in the problem, okay? Not sure how you're putting the properties into a problem. Let's assume that we have it.
Yeah.
Then if I serialize that, what kind of information you would get, like from, but that's basically the idea what we want to have, right?
Yeah.
But what are kind of, what's going to happen, first question, and what are the challenges to have like something that we want to have?
So I'll start this, and Frank, and feel free to jump in, because with my experience with the casing grounder stuff, like basically as you, it'll serialize all the information that is known to that object at that point. And so this is where I actually think that we want to define the over simulation class as opposed to pairing the problem in the survey, because that is really non-transparent in terms of like, what should be serialized when you have these two objects, they're sort of one object. So I think we should have that global like, forward simulation that has a problem in the survey. And then in that case, if your survey knows about your sources and receivers, all of that information will be serialized. Is that true?
Yeah. I mean, once everything becomes properties, then it just gets recursively serialized. So if you have a mesh inside, I don't know, I haven't worked with SimPEG enough to know exactly the structure, but if you have a mesh inside a survey or whatever, then the survey gets serialized, and then the mesh would get serialized, and then you can just deserialize it again from there.
It's actually cool.
So you would have a nested serialization, in, like a bigger container having things inside. Is that the?
Yeah. So it's just like a huge nested dictionary. There's also ways to serialize it into like a flat dictionary if you want, but yeah. And then I mean like, and then you could even come in and define your own like not in SimPEG, define your own like thesis or something has properties class that's just like a list of whatever, a list of problems. And then you could like serialize your entire thesis into a list of these serialized things and just have one huge JSON file that you can then deserialize and load into SimPEG.
That's fun. When you deserialize, this is something I left a comment on in the pull request, and because you picked up on that weird thing that I was doing with the dual H's. Do all of the things that you're deserializing need to be keyword arguments?
Yeah, so I added another comment to that just before this call. So just the way that Python treats arguments and keyword arguments is that if you pass in like a named keyword argument that matches one of the arguments, it just puts it there.
Oh, okay.
Yeah, so like it can come in as a keyword argument, but it still gets moved over to H.
Okay. So that should clean that up.
Yeah. So that's just Python.
That's handy.
Yeah.
Lindsay, what's the advantage of working with JSON? Because we're building IOs for SimPEG to be able to read them. It's a UVC formats, right?
Yeah.
Right. So right now you're proposing that the mesh can be written as a serialized JSON file instead of a UVC mesh, but it's technically the same information. It's just the way it's formatted, right?
Yeah.
So what's the advantage of going towards the JSON format?
JSON is much more interoperable with like everything else that's out there. So reading in a JSON dictionary versus like a specifically formatted text file is much, it's going to be much more generalizable. It's
still going to be a write into disk and write in, write out to disk, though, right? It's not like we're not going to be able to pass on the JSON like the information from SimPEG directly to memory for GIF tools, right? They're not going to share memory. It's still going to be a write to file, correct?
Yeah, I mean, we probably could come up with some way to do that, but like the read and write of JSON is light. I mean, the mesh, and that's what's nice about these meshes is it's like we're not actually storing all that much information. Like for a tensor mesh is pretty simple.
Yeah, no, but later you will want to do the same observations for everything, right?
Yeah, I mean, and so we can get more advanced, and like if there's things that we want to like write a piece to HDF5 and then instead serialize the filing or whatever, like we can give some thought to all of those kinds of things.
Yeah, no, that makes sense.
Yeah.
I'm happy with JSON. Yeah, that's good.
Yeah, because it's basically like it's just a dictionary, which any language can work with.
Absolutely. Yeah, makes sense.
I've done some array serialization where when you serialize the array, you actually just pass in like a data type and a length of the array and a pointer into memory.
Oh,
and so you could even do it that way. So then you're only like saving those three things in JSON, and then as long as you stay, on the same computer in the same memory, then you can just grab whatever from there.
Oh, that's great. Yeah, that would be optimal then. Do you think MATLAB could queue this? Could look at that memory block or?
I don't know. Probably. I can't say for sure, but I would guess so, because I think that it's pretty straightforward. Once you have like, okay, these are 8-byte floats or whatever.
Yeah.
It's just pretty straightforward with anything, but I'm not certain. I haven't done it.
All right, it's good to know. Yeah. Good to know. Because then that will solve exactly what we want to do, right? If you're in a current session, and you want to do operations between Python, between SimPEG and GIF tools, if things are already loaded in memory, then you don't need to pass anything. They're just accessing the same block.
That's true.
Yeah. That's true. And what's nice about actually thinking about it through properties as well is we can first of all do the rewrite to disk and then figure out how to actually get to memory.
No, sure.
Yeah.
Just looking down the future.
Absolutely. All right. Is there anything else you guys want to?
Sag, you haven't spoken.
Okay. Sorry.
So working on thesis.
Okay.
Although I was mostly writing, but now I want to rerun my examples. So it's kind of I thought like it's a nice time to put all the like IP development together into
Clean it up.
one branch and make it all work. Actually, some of them work, some of them are not, and there's some stuff needs to be need to be rewritten. So that's what I'm going to do, and potentially make some example, make it available. So that's what I'm going to do. And I'll work on the Conda install. I keep saying, Lindsay, I'm going to do it, but this time I will actually do it sometime. And that's what I'm working on. And I think potentially I might stay one more year here, I guess. So assuming that, there are a whole bunch of things that I would want to do, like in terms of more kind of making SimPEG more practical codes. Well, research good, but
We want to run.
yeah, I want to run something big, something I don't know, significant. Real. So yeah, actually, I started looking at the solvers. It seems like people use a lot of multigrids and actually in EM geophysics. So I checked out PyMG. So that seems like pretty serious code, and then they are actually working out. I tested just simple DC problem, 3D. So for a larger mesh, actually that's faster than PyD. So if you go up to 50 cube, so actually PyMG is faster. And then how multigrid works is actually kind of nice because like once you generate this recycled stuff, then you can reuse it for a bunch of other right inside. So you can use basically the same way how you use it in a direct solver. But for EM problem, you can use for a preconditioner in the same way. So I think there are quite a few things that I kind of want to revisit, and parallelizations, and well, Dom is working on this multi-meshes, and yeah, those kind of things. Like just, I don't know, it's not really new, but we need that, and once we develop, that helps everyone. So,
it's not going to be a mystery anymore.
Right. So that's actually kind of on the tech side. I'm excited to jump in and actually work on that. So that'll be cool.
Cool. Nice.
What's the plan? You're proposing that hackathon in September. You send an email about.
Oh yeah. There is it's the unearthed. Sorry, I'll share my screen here again. So there is a hackathon in Vancouver through Unearthed. They're a company out of Australia, I believe. And they've run a number of these, and I think it'll be just really interesting to see how it operates, what kind of problems people are interested in tackling, like who shows up. Yeah, so I think it's an incredible opportunity. So I think the way it works is they've got data sets and like a handful of problems that they're interested in tackling. They sort of kick it off on a Friday, and then there's a whole weekend to develop and deploy something. Franklin, have you ever been to one of these?
No.
No. Okay. Yeah, like I think I can circulate the link on Slack. So I don't entirely know like how problems are scoped or things like that, or if you have free reign. I imagine like they pick something big enough that anybody can
chip or something. Yeah. It's pretty broad.
Yeah. So.
I think you can work on it early. That's what I was reading, right? As long as it's you releasing your codes. It's either you do it on site or you can do it ahead of time.
Yeah.
But as long as you're releasing all your source code.
Yeah. Yeah. So something to think about. I don't know if there's like a specific problem you guys want to just hit on and make something.
I don't even know, what are the data sets? Yeah, I was looking for.
I don't actually know.
You need to register to be able to see it.
Yeah. And Doug seemed very supportive of this, so I think if people register and want to.
Go for it, guys. I'm not going to do the work. You guys go ahead.
Yeah. So.
It's mostly mining focused.
Yeah.
Yes. But there's like, tons of different disciplines that are participating.
Yeah, so like I think it'd just be I'd be really curious to see what this event is like. I'm obviously not going to be here. So
$50.
Is it for the team or it's per person?
I think per person. They provide lunch, maybe?
I think they provide food.
Some coffee.
Yeah.
Oh!
Coffee.
Free coffee. Want a cup of coffee there?
As much sugar as you want in your coffee.
All right. Yeah, so give some thought, and if you guys want to scope something out, I'd be happy to like chat. And once you know what it's actually about, just sign up. Cool.
Merge it out.
Cool.
Bye, everybody.
Bye, guys.
Bye bye.
Yeah.